So continuing with our Matlab fundamentals, let's actually learn or recap how do we enter vectors and matrices. So my vector U, let's be very unimaginative, so we're going to call it 1, 2, 3. That's when I cannot think of anything else on a Friday morning. So this is a row vector. A built-in function, size, will tell me what the size of this vector is, and this is very useful to have, to just inspect whatever object you have. What is size of A? It's a number, so it is a matrix. It's a very trivial matrix, but it's a matrix. It's treated as a matrix 1 by 1, or a vector 1 by 1. Or both. So then we can have U transpose, which will give me a column vector. If I wanted to type in a column vector immediately, okay, I need to be able to go, so 9, 8, 7, 6, another unimaginative vector. And if I wanted to do a matrix, 3, 4, 5, minus 1, 3, 0, and 2, 3, 7. A little more variety. So basically, the moment I want to go into the next row, I need to enter. Now, what happens if I actually want to put 4 numbers in one of the rows? Can that happen? It's going to yell at me. So Matlab yells at me in red. So when it shows red text, whether you understand the text or not, you did something wrong. It's attempting to tell you. It has certain pre-programmed ways to tell you this is what's wrong. If you don't know what word concatenate means, then you might be in trouble. So pull out your dictionary. Okay. So basically it's telling you it's not consistent. You have 4 elements in one of the rows and 3 in the others. You can't put those together into a matrix, and you cannot. So it is correct. Okay. Now, so A stayed with it. Just monitor here is a variable. You will actually see A here. And you can monitor what do you have in the workspace. Now, if you want to clear your workspace and remove everything from workspace, you're going to say clear. And you will see that all of these things are disappearing from the memory. So if I try to reach A, it's going to tell me that it's undefined. I have not defined it yet. I want that matrix back, so I'm going to use my arrow key to redefine my A. And then transpose operation basically flips rows and columns. I can see that my 3, 4, 5 is not a row again, but now it's a column. All right. Now we will learn how to define certain matrices. And then basic operations. So I can actually multiply matrices. Let me just remind you of that. So let me say vector x, 1, minus 5, and 90. Because I feel like it. Then A times x. Whoops. Yes. It can actually get smarty pants. I had a typo here. It says undefined functional variable A. Did you mean A times x? Yes, I meant uppercase A. So this is what I again mean by programming environment. It has certain helpful things in there. Okay. So I can do matrix multiplication in the way I would expect to do. But if I wanted to do A times x prime, can this be done? No, because my dimensions don't match. I have 3 by 3 and 1 by 3, and it's going to tell me inner matrix dimensions must agree. Now let's create some matrices. So in a lot of ways, sometimes you have predefined matrices, and matrices define a lot of things. One thing that I mentioned last time is that they are linear maps, or in general, they're maps from a world of vectors to a world of vectors. Okay? So if I need to rotate my entire object, okay, anytime, so think about it actually in movie industry or video gaming industry, anytime you're rotating something, okay, there's a matrix operation working on that is actually making that change. Anytime you're stretching something or squeezing it, basically there's a matrix operation equivalent of, say, 2 times x plus something, okay, that is actually working on those vectors and stretching them out. Okay. Anytime you actually click, so you could also shear, so shearing is something kind of extending in this direction. Okay. So every time in your word processor, you're clicking on italic letters. Okay? Italic letters is a regular font that has been sheared. Okay? So there's actually a little matrix multiplication going on that is taking your letter in its pixelated form and basically mapping it to this sheared letter. Okay? So there's the moment you click on that, the matrix multiplication is working on all of the little pixels in that letter and shifting them to a different letter. So in that sense, like matrix multiplications and transformations are everywhere. But sometimes we actually have to define random matrices, or we need to input for certain data that we don't know. And in subsurface, that is very common. It's called uncertainty. Okay? I know that I have a sandstone formation somewhere down there. Okay? And I know something, I took 1 sample or 3 samples out of it. And those samples tell me that my porosity is somewhere between 0.15 and 0.25. So if I actually wanted to generate now multiple virtual samples or virtual porosities for my reservoir model, okay, they're not just 0.15. I don't want to put them to a constant. They're not just 0.25 either. They're somewhere in between. Okay? So if I actually wanted random number or selection of numbers that are kind of evenly distributed in that range, I would like to be able to automatically do that. And there is a pre-built function that does that. So function rand will actually just create a matrix, and what's nice about this environment, it actually suggests for you what the forms of this function are. Function rand will actually, so let's do function rand 3 by 4. So it's going to give me a 3 by 4 matrix of random numbers, and those random numbers are in the range 0 and 1. Now I mentioned that my porosities are always in the range 0 and 1, so this is always already a world of some porosities. But if I actually want to restrict them to the range I like, okay, I can shift this, stretch it. And we know how to stretch things, so if I just multiply things by 2, suddenly I would stretch this from 0,1 to 0,2, right? And if I wanted to translate it plus 3, okay, so I would have a range of numbers between 0 and 2, shifted by 3, so they're going to be between 3 and 5, correct? Okay. So general formula, if I wanted to stretch 0, 1 to AB, whatever AB are, so in this case, A was 3, I wanted to do 3, and B is 5. Then the way you're going to do this stretching, this is B minus A plus A. That should give me the range between A and B, because these numbers are between 0 and 1. And you can see that random function, every time you call, it has a slightly different range of values, but they're still staying between 0 and 1. So that's how random numbers generators work. They're kind of instances. So now if I wanted actually my porosities, I'm going to put them between 1.15 and 0.25. Okay. Porosity, everybody knows what porosity is? Fraction of pore space in a piece of rock. So there is empty, rocks are sponges effectively, just with a matrix that is very hard as opposed to your sponge that you use for dishes. Or I have small children, so for me, I think of sponges as diapers. So essentially, that sponge has a fraction of pore space, and that pore space is connected. That's where our fluids live in subsurface. And fraction of those in a regular sandstone, which is any typical building stone as you move around, or on this campus, limestone is a common building stone. Their porosities are somewhere in the order of around 20% as well, often. So basically this gives me that range, 20% or 0.2. So now when I do this scaling, I will see that my numbers are indeed between 0.15 and 0.25. So I can scale this any way I want. If I just type in random of 3, it's going to think it's 3, 3. So it just shortens the writing. So I'm going to get 3 by 3. If I want a vector, I can do 3, 1. Or any size that I'd like. So rand is very cool. Rand I of 3, 4 will give me numbers that are in range 1 to 3. So it's going to actually give me a 4 by 4 matrix, and numbers are up to 3. They're integers. So if you want integers for some reason, well, here's one way to get integers. Another built-in matrix is identity matrix, and it's called I. If I just say, again, I of 3, 5, I'm going to get the 3 by 5, where on the first diagonal it's going to give 1s and 0s everywhere else. Yes?
So the rand I 3, 4, how come you write in 3, 4 that it gives you?
So it's taking this as a size and this as a range of numbers. And if you ever forget, which you will, there's something called help that is pre-built for every function that is built in. So you type in help, rand I. It's probably going to give you more text that you're willing to read. But you go to the beginning. It's actually a typical problem. Okay, pseudo-random integers from a uniform discrete distribution. Okay, let me enlarge this so I can actually properly read. So it gives you Imax and returns n by n matrix containing values that are drawn from 1 to Imax. Okay, so that's how it's built. Okay. And you have to know that, which is why help is there. Of course, all of the talking I'm doing is from memory because I know these functions already. But certain details, so all of them are loaded in the sense, or it's called function overload. There is multiple ways I can call every function. Okay? So I can say rand of 3 and rand of 3, 4. And in those two cases, it's going to interpret input differently. And we will learn about, in programming, about control loops that enable it to do so. Okay? But for a lot of things, I want multiple uses. Right? So in this case, rand 3, 4, again, it's going to take this as a maximum number. So it's going to give me numbers between 1 and this number here. And it's going to give me, this is the size. Now, if I wanted actually 4 or 5, I think I need to put in this. So then it's going to take these last two numbers as size of the matrix. If I just type in 4, it's going to think it's 4 by 4. And that's something you have to know. You know, somebody who designed the function has built it that way. And sometimes it's more, and sometimes it's less intuitive. And sometimes it changes. So in a new version of Matlab, it could slightly change. So you have to be on a lookout. You also have to be on a lookout. There are certain things that don't make sense. So I don't know. What is it going to do if I put 0? Is it going to put range between 1 and 0? Or is it going to have a problem with it? Whoop, it's going to have a problem with it. But some smarty pants programmer might have decided, well, okay, if you put in a 0 there, will give me numbers between 1 and 0, which is zeros and ones, right? Well, they didn't, okay? And it's going to result in error. So the point I'm making here is I want you to be alert to the fact this is a bit of a black box of how it works, and a lot of programs are, but beware that humans designed them, and therefore they have limitations and they have errors, and they're not reading your mind. You have to read theirs, okay? And help function enables you to do so to a certain extent, to the extent that is well documented, and that you are willing to read that one page of text. Okay. All right. So I, again, will give me an identity matrix, and that can be helpful in a lot of applications. Now, more built-in functions will tell us how to actually do get vectors, and it's very useful to actually have a vector in certain range, and not just range, but actually evenly spaced numbers. Now, why? In numerical methods, I work with physical domains, and I want to simulate something. And that's something I'm going to typically produce a solution at regular intervals. And the more memory and more time I have, my intervals will be smaller, and I'm going to get like to a very nice continuous distribution of things. But if I don't, it's going to be very discrete. So I'm going to put things. So that's really just like this screen. Screens have different sizes, and the more pixels they have, the more beautiful they look and more continuous. But if you zoom in, they're still pixelated. Okay? So the same in numerical methods. So my first step in designing a method is to what's called discretize my space. So let me discretize my space between 0 and 100 and put 11 points that I'm going to compute on there. I'm going to say vector x is linear space between 0 and 100, and give me 11 points that are evenly spaced. Well, those points are 0, 10, 20, 30, and so forth. So try it out. And again, just to alert you that x that I have just defined has shown up here. It has overwritten whatever I had as x before, and I had something. Okay. I could actually, this is so pre-programmed that there is another function that will give you log space for the same. Oh, whoops. It's going to go to 10 to the 100, so let's do 1 to 5. So log space will give me between 10 to the 1 and 10 to the 5. Let's do 5 points. So 5 points between 10 to the 1 and 10 to the 5 is 10, 100. So it's basically, this is taken as logarithm of. Okay. And size I already mentioned, so I can check the size of anything by typing in size. Now, how am I going to refer to numbers? So I have defined my A. I already have a 3 by 3 matrix A. So the way you grab A22 is you actually say A of 2, 2. Okay. So that is just grabbing element A of 2, 2. Now, if you actually want to do entire second row, You're going to do, and this is super helpful, you're going to do colon, saying everybody. Colon means everybody that you have on this address. Okay? So that's -130. And that in itself is a vector. So I could actually say y equals to a of, okay? So now my vector y is -1, 3, and 0. And how do I refer in y to 0, my third element? Y of, how do I get that 0? How do I grab it? 3. But if I wanted to grab that 0 in matrix A, what do I do? Okay? So basically I now have, well, that same vector is in 2 places in memory. One is called y, and one is within A. And they're 2 different objects, so I grab this number 0 in 2 different ways. So for y, I'm going to do y of 1 is my -1, y of 2 is 3, and y of 3, we already saw, is 0. Okay. Not only this colon is actually even more useful than that, especially if I had a larger matrix, but I can exemplify it. So let us remind ourselves how A looks like. Okay. I could do the same, let me just repeat, I could do the same for columns, except that in column world, I'm going to refer to the second column as everybody, comma 2. So that's my everybody in the second column. Okay. And that's 4, 3, 3. I can also do any range. So I can say A of 1 through 2, comma 2. What is that? So I live in the second column, and this is now actually taken as a range from first to second element. It's only 2 of them, but okay. So what are those? What are those numbers? It's in second column, first to second row. Huh? 4 and 3. Okay. Second column, 1 to 2. Address is 1 to 2. First and second row. What is the size of this vector? Two by 1. Yes, I can check that. So this is obviously more fun in a larger matrix, okay? But you can actually take any element to any element. So I can do this, or I can say, well, first row, this is equivalent to saying everybody, but 1 through 3, right? 3, 4, 5. So this is so-called colon notation, and it's really useful for grabbing things. Now, I can also reassign things. So my A was this, okay? I can say, well, change the entire row, third row. What do we want third row to become? Now it's 2, 3, 7. Give me some other 3 numbers. 1, 2, 3. Speaking of lazy way to define a okay? But it's easy to spot. So now I can see that I changed my entire row and made it 1, 2, 3. I can even be more bold and say everybody be number 2. So even though sizes don't match, okay? For constants, I can make that mathematical crime. It's a mathematical crime. It's a convenience. Okay? It's basically assigning a different size object to something else, but we are mentally saying, oh, everybody is a constant too. Assign it. So mathematically, there should be 3 lines here. That's different story. Okay. So there's a lot of convenient ways to do this notations. Okay. This is what we've done. Oh, and there's colon is so colon in itself. Just to, I can also refer to sizes, but it's colon on itself operates by producing. So when I said 1 till 2, it actually produced the vector 1, 2. I can actually say, well, okay, do 1 till 2, but step by 0.25. So this is an alternative to that linspace business. There's a subtle difference. I could achieve the same with both, but there's sometimes it's easier to do this than linspace. And the only problem is that now this is a vector in itself. I cannot use it to refer to locations in any matrix. Okay? It's just a vector on its own. Whereas when it has integer values, then I can use it to refer to locations in a vector or a matrix. So even if my vector y it had enough elements, let's find that something that is a linspace 4 to 7 and give me 8 values there. Okay? So even in y I have enough numbers, I cannot refer to y of 1 through 0.25. It's going to yell at me. It did something though. It produced something, but it did actually tell me that integer operands are required. So I can do this though. Okay. So just be aware of that. Now we did matrix multiplication already, so we did that. Well, let's do the dot product. So with vectors, we had u is 1, 2, 3, and let's give ourselves a v is 5, 6, 7, my unimaginative vectors. u dot v, I have to do dot u and v. So let's check that this is true. You have to do things by hand. 1 times 5 plus 2 times 6, that's 1 plus 12 is 17, plus 3 times 7, 21, that's 38. So it's good. Can I do just u times v? No. So if I give it objects that are non-scalars, it's going to treat them as matrix multiplication, and these two don't have matching dimensions, so I can't do much. But can I do this? Can I do this? So those are 2 different objects. So we again prove to ourselves that the matrix multiplication does not commute, not even in sizes, let alone in something else. So this object u times v transpose is a 1 by 1. Object u transpose v is 3 by 3. So let's do a little exercise before we let go today. These are the 2 vectors. I want you to compute angle. So this is a definition of angle between 2 vectors. Do what's needed in this mathematical environment to get the angle. and try to remember what is the definition of U, norm of U. Speed it up. For 3 by 3 vector is square root of U1 squared plus U2 squared C3 squared. Are you using calculator on your phone? Use Matlab. Whatever you can type into your calculator, you can use in Matlab. So if I wanted to actually, so there's something that I didn't tell you. It's how to do square root.
Yeah.
Uh-huh. Square root. Squirt. U1 times U1 plus U2 times U2 plus U3 times U3. Okay? Squirt. So I'm going to give that a name. I'm going to call that A. And I'm going to bring it up again and change all of these to V's. Call that a B. So then my cosine theta is dot UV divided by A times B, right? I can also cheat. Yes, there is a function norm of U times norm of V. Whoa, it apparently did not take norm 2. Oh, no, I have a different V. What do I have as U and V? Okay. And you have to tell it that it's an... What is my B? So apparently I didn't do something right. Ah! Brackets. Division. Now I get the same result as the first one. So then A cosine is this. A cosine will give me something in radians. I like degrees better, so A cos D is gonna give me, it's about 14 degrees. So just think about this. And it was very natural that you pulled out your calculator because that's where you know how to compute things. Whatever calculator do, Matlab can as well. If you don't know how to do, literally Google it. How to do square root in Matlab. Okay? And if you kind of maybe think that norm might be a function, but you don't know if it is, say help norm. Okay? And actually, not only that you can do norms, you can do different norms. Okay? Norm of x is the same as 2 norm, which is the one that we need in this cosine, in this calculating cosine theta. But norm of x1 is the 1 norm, and infinity is the infinity norm. And those are the 3 norms that we defined in this class. But so if you want to double check yourself, you can. All right. Sorry for going 2 minutes over.